what we're going to be working with today, we have all word problems today. Our word problems are going to be working with mixture and percent problems. So we're going to be mixing solutions. We're going to be mixing candy in one problem. You're going to be mixing juice. What we're going to be doing is looking at problems where you have to mix two different things to get a certain percentage of solution. It's like chemistry or science type of problems. Okay? So there's going to be a couple steps for us to follow. I'm going to show you a really nice table that we're going to use to set up the problems to make it really easy for us, because you will always set up the problems in the exact same way. Okay, so let's write down our steps first. The step 1, we want to define each percent mixture in terms of one variable. So we should only have one variable here. And we're always going to make this, pretty much always going to make the same part of our chart the variable. Okay, and I'll show you in a second. Step 2, you are going to set up a table showing the amount needed, the percent, and the percentage amount. So how much of the specific thing that we're taking a percentage of. Okay. Step 2, you are going to write an equation showing the total amount in the mixture. And you are going to be always using the last column for this. So I'm going to write a note there, use last column. Okay, so you want to use the last column to do step 3. Always the last column is what we're going to use. And then step 4, we're going to have an equation with one variable. So we're going to solve for the variable. Okay. Okay, now I want to warn you guys right now, the questions are going to be overwhelming at first. The chart will really, really help you to write the equation and set it up. You will set up the chart the same way every single time, okay? So it's not, after we start practicing a little bit, it's not going to be so bad. So let's look at example 1 first. Okay. Example 1, a chemist has one solution that is 40% acid, so one solution is 40% acid, and another solution that is 80% acid. So everything for 40% I'm going to do in orange, everything for the 80% I'm going to do in green. How many liters of each solution does the chemist need to make 300 liters of a solution that is 64% acid? So what are we working with here? I have two bottles. Okay, I have 2 bottles. This one contains a liquid that is 40% acid. This one contains a liquid that is 80% acid. So this one has a lot more acid in it, right? This one has a lot less. I want to mix them and end up with a solution that is 64% acid. Okay, so what do we need to do? We need to fill in the amount of each one. Do I know, let me get my blue pen, do I know how much of the end result I want? How much of the 64% solution do I want? Do I know that amount? Read the problem. I want 300 liters, right? So that's what we're going to fill in right here, 300. Okay, so what am I trying to solve for? I'm trying to solve for how much of the 40% and how much of the 80%. So do I know the amount of solution of the 40% I need? No, so what do you want to call it? Let's call it X. Now I only want one variable here. If I put in X amount of the 40% solution, I want 300 liters total. How much of the 80% solution would I need?
300. 580. 7,000.
It's not going to be a number. Let's think about it.
L.
I have X amount of the 40% solution. I want total 300 liters. How could I figure out how much of this one I want? Right? When I add these two together, I want it to get to 300. So if I figure out this one, I can subtract it from 300 to get how much of this one? Does that make sense? If I get my answer and it comes out to 100 liters of the 40% solution, how much would I need of the 80%? 200, right? How'd you figure that out? Subtracted from 300. Does that make sense? Okay, so this one will always be your variable. Almost always, this one will be your variable. Okay, I want the total, these two amounts, I don't know either one, right?
No, you said 100.
I said if my final answer comes out to be 100. Oh. Okay. This column is the easiest to fill out because it's all the information we already know. What percent of acid is in this solution? 40%. 40%. So let's write 40%. What percent is in this one? 80%. So just fill it in, 80%. What percent is in this one? 64. Not bad, right? Okay. Here's the part that is the most important for us. If I have X amount of the 40% solution, and 40% of that amount is acid, how many liters of acid is there? How would I figure that out? 40 times what?
48.
Times X. X. Okay. So, how much acid would be in the 80% solution?
300 minus 48.
No, not quite. 80 times 300 minus X. Okay, what is this telling me, guys? This is telling me I have 40%, I have X amount liters of acid total, of liquid. 40% of it is pure acid. So how would I figure out how many liters of acid is in this mixture? 40% times X. Does that make sense? So then that's going to give me an actual weight or amount of how much just acid is in there. Okay, we don't know the amount of, in the 80% solution is 300 minus X. So we have to multiply 80% by that amount. Okay, so you're multiplying the percentage by the amount. What would this one be? 64 times 300. So, my whole chart is filled out. We're always going to fill out the chart in the same way. First row is going to be item number 1. Second row is going to be item number 2. Third row is going to be the mixture of the two. So why don't we label those off to the side so that we know how to set up the chart each time. So first row is always item number 1. Second row is always item number 2. And the third row is always going to be the mixture. Now in most cases you're going to have all of the information for the mixture already given for you. Sometimes, and in one of the examples it will be like this, the variable is going to be in the mixture part as well. Okay, so you just have to read the question. Okay. The first column is always going to be the amount of the original item. Okay, so first column is always going to be amount of the item. Let me do that in black pen. So first column is always going to be amount of item. Okay. There are going to be some problems where we're working with money. The second column will always either be percent or cost. Let's just put a $sign. Okay. So second column will always be percent or cost. So this one should not have any variables in it at all. You should either put a percentage or a price. The last column is always going to be your totals. Okay? So the last column is always going to be your totals. In this case, it's how much acid total. How much of the pure thing that we're looking for. In some cases, it's going to be total cost. Okay? What we're going to do now is we are going to take this last column and we are going to write an equation. The amount of acid in this one plus the amount of acid in this one should equal the amount total, correct? So this is part of it. This is the second part. Here's your total. So what would my equation look like? 40x plus 80 times 300 minus x equals 64 times 300. Always. This one plus this one equals that one. Always. Okay, so why don't we put a plus right here and an equals right here. Okay? First column, or first row plus second row equals last row. Can we solve this?
No.
You bet we can. What do I need to do first? Distributive. So let's distribute. That's going to be 40x plus 80 times 300. 24,000. We have 1, 2, 3 zeros there. Minus 80x equals, okay, 64 times 300. I got 19,200. Okay, now what can I do?
Subtract 24,000.
Before I subtract 24, I want to combine what?
The
Like terms. So let's combine the x's first. What's 40x minus 80x? Negative 40x plus 24,000 equals 19,200. I'm going to move this up a little. Is that better? Okay, now what can I do? Subtract 24,000.
Well, you don't add the 24 and the 1.
And this one? We can't. They're not like terms. This one has an x.
No, you don't add 100 or you don't add 24.
So those cancel, so we are left with negative 40x equals 19,200 minus 24,000 negative 4,800. Okay, now what? Divide by negative 40. Since we're working with amounts and cost and percents, should I ever get a negative answer? No. Your answer should always come out to be positive. Thank goodness it is negative divided by negative, right? So what is negative 4,800 divided by negative 40? Positive 120 what? What is x? What column is x in? Liters. Okay, so x is 120 liters. So how do I find out how much of this solution I need? 300 minus 120, which gives me 180 what? Liters. Okay, don't just box that as your answer. This is a word problem, so my answer has to be in a complete sentence. So let's write it off to the side. We will, or not a complete sentence, let's just do complete phrases because we have to label these. Well, this is 120 liters. 120 liters of what? Of the which one? 40 or 80? 40%. So let's write 120 liters of the 40% solution. I'm just going to write SOL. And then 180 liters of which one? The 80% solution. Box that as your answer. On a test, if you just give me 120 liters, 180 liters, I will give you some credit. However, I will take off points, a couple of points, because I don't know which one's 120 and which one's 180. You have to label it for me. Okay, so you need to write 120 liters of the 40% and 180 liters of the 80%. So what is this saying? If I take 120 liters of the 40% solution and mix it in an empty glass with 180 liters of the 80% solution, I will get 64% acid. And doesn't that make sense? This one has less and this one has more. So they start to, it's kind of like the idea of averaging out. Okay, that's what we're doing. You will set up your chart exactly the same way every single time. Okay, example 2, we're working with candy. Peppermint candies sell for 15 cents a pound. So I'm going to use orange for peppermint. Butterscotch candies, so I'm going to use green for that one. Butterscotch sell for 12 cents a pound. How many pounds of both peppermint and butterscotch, so now we're looking at the mixture here, should you use to create 30 pounds of a candy mix that sells for 14 cents a pound? So I know how much, I know what the cost of that one is. Will you guys see if you can fill in the chart yourselves? Alright, I want to fill out, let's fill out what we know about the 14 cents mixture first. How many pounds of this mixture do I want? 30. How much does it cost? 14 cents. So what would the cost of this amount be? 14 times 30. Okay. Alrighty. Let's look at peppermint candies now. What is the amount, how many pounds of peppermint candy will I want? X. What will the cost of that peppermint candy be? 15 cents. How much would it cost? 15x. Good. Okay, last one, butterscotch. Butterscotch depends on the peppermint, right? What amount or how many pounds of butterscotch candies do I want? 30 minus x. What would it cost? 12 cents. So how much would 30 minus x pounds of butterscotch count? 12 times 30 minus x. Who got that filled out for their chart? Raise your hands. You guys all get air high fives. Okay. What I want you to do next, by yourselves without my help, write the equation. You already did it? Who already did it? Oh my gosh. Let's write the equation then. Okay. What would my equation be?
15x plus 12 times 30 minus x equals 14 times 30.
Oh my gosh, you guys are geniuses. Okay. I know. What do I do next? Can you guys solve this? I want you to solve it by yourselves. What is my first step to solving this guy? Distributive properties. So let's distribute the 12. That is 15x plus 12 times 30. 360 minus 12x equals 14 times 30. What'd you get? 420. Okay, next step. Combine like terms. So we have 15x minus 12x. What does that give me? 3x plus 360 equals 420. I haven't done anything except combine like terms. subtract 360. So that gives me 3x equals, what? 420 minus 360? 60. What do I do? Divide by 3. So x equals what? 20. And then how do I find the next amount? 30 minus x equals, or 30 minus 20 equals 10. Okay, which one was x? Peppermint or butterscotch? Peppermint. So it is going to be 20, what? 20 peppermint or 20 pounds? So 20 pounds peppermint and 10 pounds butterscotch.
I'm ready for this.
Okay, box it. That's your answer. How? Example 3. How many ounces of a 30% orange juice concentrate? So that means, you guys know what a concentrate is? A concentrate of juice is like, it's frozen. But it means it doesn't have 100% pure juice. You know, if you took an orange and squeezed it out, that's 100% orange juice. When you buy orange juice at the grocery store or concentrate, usually they mix it with other flavors, sugar, extra juice or water to make it
Diluted.
not diluted, but yeah, just to change the flavor of it a little bit. Concentrate has a certain percentage of pure orange juice from an orange. Okay, this particular concentrate is 30% pure orange juice. Okay, it must be added to 70 ounces of a 70% orange juice concentrate. So there's a second, there's a second concentrate that's 70%, and we want our mixture end result to produce a 58% orange juice concentrate. So here's our mixture. This one, I know, this is the mixture, this is the end result, so that's why I put it in blue. This one is a little bit different than previous because we know how much of the second amount that we want. So in this case, the variable is also going to be in a different spot. Okay, the first thing I want to do is let's fill in the boxes. Let's do our items. What's item 1? The 30% concentrate. So item 1 is 30%. Let's do 30% OJ. What's my item number 2? What am I mixing the 30% one with? A 70% OJ. And what do I want the mixture to be? How much percent of orange juice? 58. So you have to read the question carefully. Even though we know the amount of the 70% concentrate, our mixture, we're trying to make a 58% mixture. So this is going to be our end result. Okay? So, I know this time information about item number 2, the second 70% concentrate. How much of the 70% do I have? Oh wait, we didn't fill in the top, huh? Okay. What's going to be here? The amount I already have, right? It's not the amount of juice, it's the amount of what? Of concentrate, the amount I have. So this is the amount of the item that I have. The item that I have is not pure juice. The item is concentrate. What does this do? This is what? Percent of pure orange juice, right? Percent OJ. And the amount of concentrate is in ounces. So if this is how much concentrate, here's how much orange juice is in that concentrate. What's going to be this one? the amount of OJ. How much in ounces pure orange juice is in each concentrate? Okay, good. We'll fill out the chart together. I'm going to do the green one first. How many ounces of the 70% concentrate do I know I have? 70. Okay. What percentage of orange juice is in that concentrate? 70. So how much orange juice is in 70 ounces of a 70% concentrate? 70 times 70, right? Okay. Do I know how much of the 30% I have? No, so let's call it X. What percentage of orange juice is in that one? 30%.
30x.
So the amount of orange juice is going to be 30x. I forgot percent here. Okay. What about our mixture? How much total will I have after I mix X amount of 30% and 70 ounces? 58%, how much though? I know how much I started with, right? 70. And I'm adding how much? X. So 70 plus X. Make sense?
Yeah. No.
Okay. What percentage of orange juice is in that end mixture? 58. So how much orange juice will be in that mixture? 58 times 70 plus X. So, even though there's actually a variable in this last column, we're still going to do the exact same thing. Column 1 or row 1 plus row 2 equals row 3. So I'm actually going to have variables on two sides this time. What will my equation be? 30x plus 70 times 70 equals 58 times 70 plus x. Okay, let's simplify. We have 30x plus 70 times 70? 4,900. Remember, there's two zeros. Equals, what am I going to do on this side? Distribute. So 58 times 70. 4,060. So 4060 plus 58x. Okay, this is something we already know how to do. What do I do next? Well, we have all the x's on one side and all the numbers on the other, right? So which one do you guys want to move? 30x or 58x? 30x? Why 30x? Because it's smaller. So that's going to give me 4,900 equals 4,060. 58 minus 30 gives me 28x. And then what do I do? Subtract 4,060. So that is going to give me 840. Equals 28x. Then what? Divide by 28. So x equals 30. Okay, so 30 what? We have to write this in a phrase. So we want 30 ounces of what? Of 30% OJ concentrate.
Ooh, whoa, that's right.
Okay, so 30 ounces of 30% OJ concentrate. Did I answer my question totally? Let's read it. How many ounces of a 30% orange juice concentrate must be added to 70 ounces of a 70% orange juice concentrate to produce a 58% orange juice concentrate? Do I need to know how much I end up with in the end? No, so we are done. So the question only wants to know how much of the 30% do I need to add. So I only have to do the work for the one.